Hello everyone and welcome to my channel. My name is Simon. I am a coder and programmer, and on this tutorial we are going to be programming a delivery robot that performs a task in a virtual world. The task involves picking up and delivering parcels in a village that is connected by roads. And by the end of the tutorial we are going to build 3 variants of the robot. The first one will be the most inefficient, moving in random directions until it has finished delivering all parcels. The second one will be a bit efficient, following a fixed route. And the third one will be the most optimal, being able to plan ahead and make deliberate decisions on where to move based on the tasks or parcels that it has to deliver. To be able to follow along on this tutorial, you are going to need to know the following JavaScript concepts: arrays and some array methods like map, filter, and slice. You're also going to need to know about classes. We will also be using the math object, some logical operators to do comparisons, and template strings. And now with that, let's get started. Before we start the project, I want to mention that I read about this project in the book Eloquent JavaScript. Some of the code that we will be using will be directly from the book, and so I have to mention that because of copyright. And now with that, let's continue. I already have Node installed in my computer, so to log values out, I'll be just using my terminal down here. And if you don't have it installed, you can just create a simple HTML page and then open that with a live server on your browser, and then right click and inspect the page, and then open the console, and everything we log will be visible on the browser console. So our robot will be operating in a virtual world, which is a village connected by roads. And we are going to create the array of the roads in our village, and I had already written the code for this entire project, so for the easiness of making this tutorial, I'm gonna be pasting down the code snippets and then following up with step-by-step explanations. So let me paste the roads, and the best way to visualize the roads is to see them as lines in a graph connecting places, and the places in our village are the points of intersection of those graph lines. So we are going to create a graph-like representation of our village, and to do this we are going to use an object whereby each property in the object will be the name of a place in our village, and its value will be an array of all the places that can be reached from that particular place, so that our resulting data structure will look something like this. Now that we have seen how this will look, let us now walk through the function that we will use to build this object using our data, which is the roads. So we are going to name our function build graph, and this edges parameter is essentially the roads, and then we will create an object and name it graph, and we will be creating it using the built-in object.create function to make sure that this object will not be deriving properties from the object prototype. And then we are going to create another inner function called add edge, and this add edge function will be taking two parameters, a starting point and a destination, and then we are going to implement an if statement whereby if the starting point is already added in our graph object as a property, we will push the destination point as one of the elements of the array of places that can be reached from that particular point. And if you have not yet added that the starting point in our graph object, we will create a new property and add the destination point as the first place that can be reached from that starting point. And then remember that our array of roads, the roads contain two connected places, so to get the individual places we are gonna be splitting each road, and here we will use the map object, which will return a 2-element array for each road containing the starting point and the end point, so that we can get the values to feed in our add edge function. We are going to be adding those edges using a for loop, and we will loop through each of the 2-element arrays to get a starting point and an end point, and then we will call our add edge function, and we will be calling it 2 times to ensure that each place in our village has actually been added as a property in our graph object. And then at the end of the build graph function, we will return our graph object. And now we can go ahead and see whether this will actually result in the previous data structure that I had shown you. To see that, we are going to write console.log, and we are going to call our build graph function and pass in the roads, and I am going to be running this inside my terminal because I already have Node.js installed. So we're going to run node robot. So as you can see, this is the data structure that will result, and it is an object whereby each property is a place in our village which will hold an array of all the other places that can be reached from that place. And now that we have now built our graph object, the next thing that we are going to do, we are going to condense our village state to the minimal set of values that represent it. And there we have the current robot location and the collection of all undelivered parcels in our village. Each of those parcels has a current location and a destination address. So we are going to create a class and name it village state, and the constructor of our class will take 2 parameters which are place and parcels. This is the current robot's location, and these are the parcels in the village. Okay, and then inside our class we are going to create a method called move, which takes on a destination, and then inside the move method we are going to create an if statement. We will check when we are moving, we will check whether the place where the robot is, whether it is possible to reach the destination, and if it's not possible, we are going to return the same state, which is this variable, this variable which represent our class state, and we will also log out this message, cannot reach the destination from this place. And then if it is possible to reach the destination, we are going to be mapping the parcels that we have, whereby if a parcel is not located at the current robot's location, its details will remain unchanged. But if a parcel is located at where the robot is, that means that the parcel has to be moved, and to move it we are going to change its place property to be the destination where the robot has moved to, and the address of the parcel will be still the same, where the parcel was addressed to. And now after moving, we are going to implement our filter, and this filter will be the actual thing that does the delivering of the parcels. So let's see how that looks. So if a parcel is addressed, if where the robot is where the parcel is addressed, that parcel is going to be filtered out, and that will mimic delivering the parcel. And then at the end, we are going to return a new village state with the location of the robot as the destination and the remaining parcels as the new set of parcels that we have. And we are going to test this out. We are going to create a state using our class, and we are going to pass in a place as the, for example, let's say we will start at the post office with one parcel that is addressed to one of the places in our village, as you can see. And then if we call the move method on this village state on our robot using this state, we expect that the new place property will be this destination, and that this parcel will be delivered. So let's see whether that works. So we are calling our robot to move to this destination where the parcel is addressed. And if we log out the place where the robot is, we expect it to be at where the parcel was being delivered. And we also expect that our previous state will remain unchanged. Remember that if we move our robot, we are returning a new state, and our previous state, we expect it to remain unchanged. And then we expect that the parcels now will be delivered, because we only had one parcel in our parcel array. So let's see whether this is true. I am going to run this code again inside the terminal. Now that you can see, the first value we are logging is the destination, which is true. Our previous robot state is at the post. Parcel array is now empty, meaning that the parcel has been delivered. So that is working perfectly. Now that we see that logic is working fine, we are now going to be putting our robot to work. And now we know that for our robot to solve a particular state, it will need to visit every location that has a parcel, and every location that has a parcel addressed to it and delivering the parcel, but it will only be doing the deliveries after picking up the parcel. Now in the next step, we are going to work on our first variant of the robot, which is the random robot. To do this, we are first going to create a helper function called random pick, which takes an array as a parameter. And what this function will help us do is to pick a random element in an array. So we will be utilizing the math object and getting a random index in our array, and then at the end we will be returning the selected element of the array. Now after this helper function, we are going to create the random robot function, and this random robot takes our state as its parameter, and it will return an object which will have one property called direction, and we will be using our random pick function here to get a random place that can be reached, that particular place in our state. Now the next step, we are going to create an initial state that we will be passing to our robots. And by an initial state, I mean a current location and a collection of parcels around the village. And to do this, we are going to use a static method. And by static, I mean that the method will be stored directly inside the constructor, and it will take our parcel count, the amount of parcels that we want to generate. And then we will create a parcel variable which will be an array, and then we will implement for loop. And then inside this loop, we are going to pick a random address from our map object, and then we are going to instantiate a place property that we will assign our parcel. But do not want any parcel to be addressed to the same place where it is located, so that way we are implementing this do loop here, so that we will only execute this final part of getting the parcel when the place and the address do not match. And at the end of this method, we are going to return our village state using the post office as the starting point and the parcels that we have just generated. Now the next step, we are going to create our simulator function, and we will name it run robot. Now this function takes two parameters, our state and our robot, and then we are going to implement our for loop inside this simulator function, and we will leave out the condition for our for loop, whereby we will implement it inside the for loop. And if all the parcels have been delivered, we will break out of the loop, and then here we will have this action variable which will call our robot and pass it our state. So if this is the random robot, this will return to us an object with the direction property. So once we get the direction that the robot has moved in, we are going to call our move method using that direction. Okay, and we already know that when we call our move method, it returns to us a new state, and then we will log the direction that the robot has moved to in our console. Also log the remaining parcels in our class. We will log the remaining parcels, and then we are going to be pretending that our robot is taking 3 seconds to move, so that when we log the values out, we can be able to see how the robot is moving. Because the code runs too fast, we wouldn't be able to see that. And I forgot to mention that inside our simulator function, when all the parcels have been delivered, we are breaking out of this loop and then logging the number of turns that the robot has taken to complete the delivery. Now with our simulator function, we can be able to call our robot, and now we will see how our robot performs. So I will call run robot. Run robot, and we will pass it our state using the static method village state.random, and we will pass it 10 parcels and pass in our robot, which is the random robot. So this is the parameter that will be used inside here as the robot. And now if I run this code inside the terminal, let's see how many turns the robot takes. Now you can see after 3 seconds it's logging the direction that it has moved to and the remaining parcels. So I think this async variant is running very slowly, so we will just remove it. But if you want to see how the robot is moving step by step, you can still get back to that. So let us run the code again. And now you can see that all the places that the robot has moved to, and at the end you can see that it has done in 79 turns. So that is the random robot. So for the next part of the tutorial, we are gonna be building the next variant, which is a route following robot, and that one follows a fixed route that goes through all the places in the village, whereby to be able to complete all the delivery of the parcels, the robot will have to go through that route twice, at which point it will be guaranteed that it has picked up all the parcels and delivered them. Now we are going to find our route. This is the route that I will be using. If you want to use this, there is a link for the source code in the video description. And what you need to make sure is that this route is passing through all the places in our village, and it doesn't matter even if the robot has to go through a place 2 times, as long as the route is complete. And now we are going to implement our route following robot. And now this time, since we want our robot to remember things so it can make and execute plans, we are going to be making use of robot memory. But don't worry about that, we are going to be saying how that will look like. So we will implement our route following robot, and we will name it route robot, as you can see. And this one takes a parameter, which is the memory, and this memory will essentially be our route. The memory will be our route, and every time our robot makes a turn, it returns to us an object with the direction holding the first element of that memory array, and then it will remove that direction that it has moved to outside of the memory. And every time that the memory now it has nothing in the memory, it is going to repeat the same cycle again to make sure that it goes through the village 2 times, and at that point we will be guaranteed that all the parcels will be delivered. So we are going to make our few updates to our run robot function, as we are going to be reusing that. First, let's comment this one out. So in our run robot function, you can see that this previous robot was taking the state as its parameter, but this time it will be taking the memory instead, and we will be passing our memory here on top as the third parameter. So every time we call our robot, it's returning to us a direction and the remaining memory, and then we will be moving to that direction. Okay, moving to that direction. And remember that this now route robot is returning 2 properties in this object, a direction and the remaining memory. So we will update the memory. We will update the memory the memory that is now remaining after making that move. So that will be action dot memory, to make sure that we are updating our memory every time we move around. And now we are going to call our route robot and see how it performs. We're going to call that function run robot and pass it our village state with 10 parcels. We're also going to pass, second parameter is the robot. Pass the robot there, and the third parameter is the memory, which is our mail route. And now if we are going to run this code and see how many turns our robot is taking to complete of the parcels. So I'm going to call node robot are getting an error. So let me see what went wrong. It's saying that the robot is not defined. Robot is not defined. Oh, here when we call, we are supposed to pass the route robot as the robot parameter. We now call that again, robot. You can see that it is completing the task of delivering 10 parcels in just 21 turns, and the turns that it takes to complete the delivery will always be less than twice the length of our route. So you can see that this robot is performing much better than the random robot. And now in the next part of this tutorial, we are going to be making more improvements on this robot, because still we cannot term blindly following a fixed route as intelligent behavior for our robot, because the robot can do much better if it can be able to take deliberate decisions on where to move based on the parcels that need to be delivered. So the next variant that we are going to implement is the path finding robot, and this one now finds its path, deciding where it will go based on the parcels that it has to deliver. Now we will create a function called find route, and this function will be responsible for finding the route that the robot should follow. And this function takes 3 parameters: our graph object, a starting point, and a destination point. And now when the robot decides to move to a particular place, it will be calling out this function, and it will be getting a route that it will follow to move to its destination. Now the first thing that we are going to do, we are going to create a variable called work, which is an array, and this array will store the places that we need to explore. And as you can see, the first place that we will explore is the place that we are at, and the route that got us to this place will be an empty array because we are already at this place. And then for each item in our work list, we will create a for loop, and we will loop through each of the items in our work list. As you can see, we get the position, the place that we are at, and the route that got us to that place. Then we are going to create another inner loop. We will loop through all the places that can be reached from the place we are exploring. As you can remember, our map object is a graph, and each place in our graph has a number of points that can be reached from there, and those points are stored in an array. So we will explore those places, and if we find a place that is equal to our destination, we will be returning our whole function, and we will be adding that place to the array that had gotten us to the place that we are exploring. And if that place is not equal to our destination, and we previously had not included it in our work list, we will be pushing that to our work list to explore later. We will be pushing that to our work list to explore later. And we will also include that place in the route that had gotten us to it. So that code will look like that. And now we are done with this function. Let me go through a step-by-step explanation of the function. This is our graph, and this is our starting point and our destination. We create a variable called work, storing an array of points that we will explore together with the route that got us to those places. We create a for loop to loop through the items in our work list, whereby we destructure the place and the route, and for each place we create a for loop to loop through all the places that can be reached from that place we are exploring. And if a place is equal to our destination, we know that we have found a complete route, and we return our function, our route finder function, adding that place to the route that had gotten us to the place that we were exploring. If a place is not equal to our destination and we had not previously explored that place, we will be adding it again to our work list together with the route that had gotten us to the place we are exploring. And now this function will now work correctly, giving us a complete route when given a starting point and an ending point. And now the final part is to create now the pathfinding robot, which is now goal oriented. Our route finder function can be a bit complex to understand, but if you follow it closely step by step, everything will click. And now that we already have our route finding function, we are going now to create our final robot, and we will name it goal oriented robot. And as usual, this one takes our state, and here we are just destructuring the place, the location, and the parcels, and we will also be passing it the route. And now inside this goal oriented robot, we are going to create an if statement, and if the length of our route is equal to 0, our robot will have to decide where to move, and it will do that by checking out the first parcel in the list and checking the location of the parcel. If the parcel has not yet been picked up, and that logic we implementing by checking that the place where the robot is not equal to where the parcel is. This means that the robot must go to pick up the parcels, and here we will call our route finder function, and this will populate our route. And the other part of the if statement, if the parcel is already where the robot is. The robot is going to find the route to the delivery address of the parcel, and as usual, in the end it will return a direction which will be the first place in the route, and it will be updating its memory. If we can go through this function quickly, it just checks whether the route is equal to 0, checking out the first parcel, making a decision based on whether the parcel has been picked, then returning us a direction and a memory. And now everything else will be the same as the route following robot, where we can now call our run robot function with our village state, our goal-oriented robot, and an empty memory, which is an empty array. So let's run this and see how many times this goal-oriented robot will complete the task of delivering 10 parcels. And first we are going to comment out this other code we were running here. I am going to run this inside the terminal, calling node robot. I just forgot to pass in the number of parcels. This is working with the default 5 parcels. Oh, we are getting an error. Telling us that route.length cannot read properties of undefined. So if you have been following along with me, you might have gotten this error. And that is because the previous version we were using, the route robot, we were passing it only one parameter, but this goal-oriented robot is taking 2 parameters. And since we were reusing our run robot function, we also need to update. We will have to update our run robot function and pass it the state as well as the memory. And now if we run this code, that error. Let's run our goal-oriented robot with 10 parcels so that we can compare with the previous versions. Now I'm going to call node robot. Now as you can see, it's the error is gone, and now it is logging out the number of times that it has taken to delivery, and it has done the delivery for the 10 parcels in 18 turns, and the previous version was finishing in about 21 turns. So this one is a little. And now we will end this tutorial at this point. I got this tutorial from the book Eloquent JavaScript, and if I get a download link for the PDF version, I will be leaving that in the video description, so you can check that one out if you want to read more about this project. And also the source code for the project will also be available in the video description. And if you love this tutorial, make sure that you hit the like button. If you have not yet subscribed to the channel, please make sure that you do. And I will see you in my next video.